Well, I want to welcome everybody to thank you for joining us to the LA chapter Zoom meeting. I'm excited about what we're talking about today with the PS. The meeting has been recorded. It will be posted on the website. I ask that you mute your lines unless you are asking a question or speaking. The mute button is the bottom left corner of your screen. If you're calling in by phone only, you can mute and unmute by hitting *6. Do we have any new members here today? If you'd like to join CG, you can apply at cg.org. I wanted to make an announcement that Brian Campaign of Forensic Analytical has been generous enough to donate a Starbucks gift card. All facility associates will be eligible to be entered into the drawing. We'll announce the name at the end of our meeting today. With that, I'd like to introduce guest speaker Michael Estes. Michael is Vice President of Business Development for Kias and has been with the company since 2017. Michael has over 18 years in both sales and sales territory development, initially starting his Kias career as a sales director in the Mid-Atlantic region. His background includes the sale of building materials, industrial MRO supplies, and mechanical fabrication equipment. He's also served several years experience managing and negotiating service contracts, master service agreements, and GPOs. Michael grew up in Washington, D.C. metro area. He studied business finance at Towson University. He's married and lives in Maryland with his wife, daughter, and 3 boys. Michael, thank you. The floor is yours.
Thank you very much. Let me share my screen. Perfect. And you can see that, correct? Just making sure.
Yep.
All right. Excellent. Well, thank you very much for the introduction. As you mentioned, I'm the Vice President of Business Development for Aquis Solutions, based out of the DC area. And I cover the entire US with my main focus on AHU optimization as it relates to energy savings. So today we're going to discuss AHU coil and tube restoration, driving improved IAQ and energy savings through innovation. And with that, let's begin. So before we begin on the topic of coil and tube restoration, it's important that we understand the root cause of the issue. And that root cause is biofilms. So what are biofilms? These are communities of microbes, including viruses and fungi that grow on a surface and live for an extended period of time. We may be familiar, or you all may be familiar with the concept of microbes floating around freely in space in what you would call their planktonic state. Biofilms are different in that they appear on a surface, on surfaces, and where microbes in a planktonic state are easy to kill, microbes that exist in a biofilm are very difficult to kill. And the main reason for this is a feature which is called the EPS, which stands for extracellular polymeric substance. Biofilms are resilient, highly resilient and impervious to common cleaning chemicals and UV radiation. And they're also largely responsible for the proliferation, spread of pathogenic agents such as Stachybotrys, Staph, Legionella, and others. 90% of harmful pathogens live and grow in biofilms, and even COVID-19 exists inside biofilms. So now let's look at a brief video here about biofilms to help everyone understand their behavior. And what you see here, a biofilm will begin with a single bacteria landing on a surface, and it will begin to quickly multiply. That microbe then joins forces with other types of microbes and bacteria and expands over a surface area. It begins to form layers upon layers upon layers. And really there are 3 things a biofilm needs to survive. And that's moisture, temperature, mainly cooler temperatures, and surface areas. Biofilms will actually communicate. You see here what they do, it's called quorum sensing. This is when individual microbes communicate with other individual microbes by sending signals. They communicate when it is the appropriate time to form the EPS. And that's what's happening here. They also communicate if there's a perceived threat. This is definitely a very organized and intelligent community of organisms. So over time, when one of the key elements to support the biofilm's existence is depleted or missing, the biofilm will begin to break away, slough off, and enter the atmosphere, as you'll see here. These individual microbes will float around in the air in their planktonic state and seek another location to begin growing a new biofilm. Okay. So let me know a little bit about biofilms. What is the impact of biofilms on an air handling unit? There are actually a number of ways that biofilms impact an air handling unit. The first is in standing water. This is an excellent location for the growth of biofilms. Rust, corrosion also add to the formation of biofilms. Aging fiberglass, insulation, and coils are all places that biofilms thrive. The air handling unit is a known amplification site for microbial growth. Biofilms also like to spread out and grow, and the more surface area, the better. We're going to dive more deeply into the coils, but before we do, we'll spend a little bit of time on the balance of the air handling unit. So what is our ability to impact biofilm growth in an air handling unit? The first would be the presence of standing water. Inside the air handling unit, your ability to reduce the amount of standing water will greatly diminish the presence of biofilm. There are coatings available that can repitch pans to reduce or eliminate standing water. One of the other key elements is the removal of rust or corrosion. It's a known fact that bacteria will thrive in iron-rich water. So in a rusty condensate pan, bacteria can grow as much as 100 times faster than they would in clean water. Also, the elimination of voids, low spots in the air handler are key. Smooth, flat surfaces that drain well are ideal, and they stop the accumulation of water and debris that harbor the growth of biofilms. And lastly, the use of antimicrobial coatings is a great assistance. There are antimicrobial impregnated insulations and coatings for metal or fiberglass. Likewise, there are even antimicrobial impregnated metals that can be used in an air handling unit. Antimicrobial coatings have been shown to reduce colony forming units of bacteria by up to 99%. So how can we measure the presence of biofilms on a surface, whether it's a cooling coil or a condensate pan? And the best way that we have found is it's called ATP testing, or adenosine triphosphate testing. So what is ATP? ATP is a molecule that exists in every living cell and carries energy to the cell. This test seeks out the presence of ATP. It can be conducted in 5 minutes or less, and it's the perfect test on the spot to make a quick determination if the surface is clean. And how is ATP measured? ATP is measured in RLUs, or relative light units. Much as the chemical reaction in, say, a firefly, the ATP is reacting with a chemical, and that chemical will glow in the presence of ATP. The ATP meters are measuring the intensity of the light created by the process. This is called relative light units. This is directly proportional to the amount of microbes on the surface. So basically, the more microbes, the brighter the light. And in our case, we conduct the test before and after coil restoration to measure a quantifiable reduction in biofilms on a surface. So with that, let's get into cooling coils and begin the discussion of coil restoration. Here's a typical cross-section of a cooling coil. This is the view of the side section of the fins from the side angle. As I mentioned before, biofilms need surface area to grow. And a cooling coil is really nothing but surface area. A typical 8x5 cooling coil has approximately 9,600 square feet of surface area. Unchecked, biofilms will run rampant on a cooling coil and significantly impact the performance of that cooling coil. Most facilities typically rely on traditional methods of cleaning coils. These include a garden hose, maybe a pressure wash or a steam cleaner, combined with some caustic or acidic type cleaner. These methods typically clean the outer 2 to 3 inches of each side of the coil. They fail to penetrate deep within the coils and eliminate microbial growth or biofilms. You would see a marginal improvement in performance once these processes are done. Today, we're going to talk about a process we call coil restoration, which is a more comprehensive or in-depth cleaning of a coil that combines a sanitization process with a unique probiotic technology that will clean a cooling coil to the center and unlock lost system capacity. So, how does it work? There are 3 elements to the process. The first is we use a eco-friendly probiotic. And this probiotic produces an enzyme containing biosurfactants, which attack and dismantle the biofilm. Second element is heat. We're able to get 280-degree temperatures in and through the coil to effectively loosen stubborn biofilms and other types of fouling. And the third is pressure, anywhere from 1,200 to 1,500 PSI, depending on the coils, again, to penetrate deep within inside the coil and also get that 280-degree temperature through. Another layer of probiotic is left on to provide ongoing microscopic cleaning. And the key is between all 3 of these is the midpoint of all 3 elements. And it's important to point out one of the key differences between steam cleaning and using superheated water is the volume of water combined with the temperature. Steam may have the temperature, but not the volume to penetrate the coil. And a pressure washer may provide the volume to penetrate the coil, but it doesn't achieve the temperatures necessary to remove fouling. And none of them utilize a probiotic. So let's look at the process. Coil restoration process, fairly, again, straightforward. Step 1, we have a technician apply the probiotic. Step 2, the coils are sanitized with the superheated 280-degree water at 1,500 PSI. Step 3 is 1 and 2 repeated until the desired results are achieved. And we can visibly see, and we'll show that later. And then lastly, another layer of probiotic is applied to continue protecting at a microscopic level. So here's another video. We're going to take a look at the actual process in action. So going over the steps, we have step 1, which we're applying the probiotic. And the first layer of probiotic, we actually put a surfactant into the probiotic to help it adhere to the fins of the coil. That first layer is going to actually steep for several hours, and it depends on the level of fouling, but typically it's going to be anywhere from 2 to 4 hours. Once it's steeped, we come back with a specialized machinery. It's producing superheated water at 280 degrees, as I mentioned, between 12 to 1,500 PSI. We're removing any type of fouling. We're removing the biofilms that have released, and we're also making sure that the technician addresses it from both sides. The technician is going to go from the upstream side and the downstream side to make sure that the superheated water is penetrating fully and the contaminants are being lifted. What we're looking for is full penetration of that coil. And what you'll see here in that next portion is the technician on the other side, we know when we need to repeat the process as if we cannot see the steam coming through. And that's what we're looking at here, is full penetration of the coil. So what's the difference between coil restoration and a conventional cleaning methods? One, Typical coil cleaning methods use pressure washers or steam. We're using 1500 PSI superheated water. Typical methods utilize toxic chemicals that may have odors or VOCs. Everything that we're using is GRAS listed or generally recognized as safe by the FDA, even as it's as a food additive. So technically you could eat this. I wouldn't eat it, but you can, according to the FDA. Also, there's no VOCs. The typical cleaning products also are corrosive or acidic, and we're pH neutral, non-corrosive to metals. And then finally, other methods do not effectively eliminate biofilms and get down to the IAQ concerns of cooling coils, where using a probiotic, we're able to address those IAQ concerns. Okay. So with that, I'm going to move into another topic, which is tube restoration, where before we discuss the restoration of the exterior of the air handler or air side of the coil, we're going to be focusing on the inside or interior of the copper tubes. So looking at the same coil as before, we see another opportunity for improved efficiency. The copper tubes are fouled with biofilm, mineral scale, and debris. And what you see here is this, the boroscope of the interior of a cooling coil shows significant mineral scale and debris. Also, we show MIC or MIC, microbial induced corrosion as well. And these all lead to decreases in heat transfer as well as disruption in the flow of chilled water throughout the coil. So what can be done? We look at a process that utilizes the same probiotic technology as the air side or exterior coil restoration. So in this case, we're using the probiotic in a foam, a dense foam that's injected into the cooling coil to break down and remove the biofilm buildup. That foam is pushed through the coil and recaptured on the other end. The biofilm and scale and debris being removed will improve the performance and flow to chilled water. And what we're trying to do is impede the further corrosion of MIC or microbial induced corrosion. All of this is designed to extend the usable service life of that cooling coil. So how does the process work for tube restoration? Again, very straightforward. First, we're going to close the main gates and isolate that coil. Second, we're going to make sure we need an inlet and outlet to that coil. And we're connect a supply and a discharge for the foam. We're going to push the foam through the cooling coil and the foam emerges white on the other end. We're going to allow that probiotic to then steep for up to 2 hours, followed by another push. And then the coils are flushed with clean water, disconnect the hoses, and open up the main gates. And you can use your coil again. So now that we talked about biofilms, we're gonna switch gears to the energy savings. So we talked about IAQ. From here, we'll discuss energy savings. And to begin the discussion, I'd like to talk about the components of the HVA system that consume energy. It's important to know everything involved. First, we have the air handler that contains supply fans, return fans, and it moves unconditioned air across the cooling coil. We have the chiller that provides water to the cooling coils. We have the pumps that deliver the chilled water to the cooling coils. And we have the cooling tower, which takes the heat removed by the cooling coils and expels it in the atmosphere. See, the common denominator here is that all of these components are designed to serve the cooling coil. So inefficiencies caused by fouled cooling coils cause an exponential increase in energy consumption for all of those components in the system. So specifically, what happens in an air handler that consumes energy? First, we need to look at a properly running air handling unit. Okay. Once the air handler turns on, we have warm, unconditioned air entering the coil in a uniform velocity. The air passes through the cooling coil, and the cooling coil removes the heat by means of the chilled water. The cool air comes off the cooling coil in a uniform manner and is delivered by the blower to a given space in the appropriate amount. And that's an ideal scenario. So 2 areas where energy is consumed in this process is the blower, which is operating at a specific speed, and the chiller pump, which is providing a specific flow of chilled water to the coil. So where do things go wrong? In poorly maintained coils, biofilms will colonize and grow on the thin surface, slowly but surely reducing the clearance between the coils. Here on this slide, we can see it, but it's often the case where biofilms are invisible to the naked eye, but can still impact the coil. In worst case areas, the coils become completely impacted or obstructed. You further diminish the capability of that coil. So what happens here between the blockages and the biofilm growth, in the very narrow space that exists between the coil, there's less and less space for air to flow. As a result, the blower needs to work harder. That blower now needs to ramp up to pull through more air to provide the appropriate amount of conditioned air into the space. Okay. The second area where there's a problem is on the coils themselves. So fouled coils have a diminished capacity to transfer heat. So as a result, instead of getting a uniform front of conditioned air leaving the coil, we have lukewarm air leaving the coil. And what happens is the chilled water system needs to provide more chilled water to this coil to provide the appropriate amount of conditioned air to the space. So there are 2 areas where energy savings opportunities. As you see here, we have reducing the fan energy by increasing airflow. There's a cubic relationship with fan speed. So a 10% reduction in fan speed equates to a 27% reduction in energy uses. Likewise, on the chilled water pumps, a 10% reduction in the flow of chilled water equates to a 20% reduction in energy usage. So increased cooling capacity is driven by increased thermal conductivity, increased airflow, and increased water flow, which is highly interactive. So how do we know these energy savings are real? Well, one way we know this is because ASHRAE tells us it's true. In 2006, ASHRAE conducted a study on this exact topic that we're discussing today, the topic of coil cleaning, and this is what they found. They conducted the study in a high-rise building in New York City on one 40,000 CFM unit. The coils were cleaned using traditional methods, and they did an M and B study to measure before and after coil performance. And what they did, they looked at 2 things, primarily airflow and cooling capacity. As far as airflow, they found a 14% increase in airflow. That's a pretty significant increase in airflow. I'll just point that out. And also a 16% increase in cooling capacity. This equates to an estimated 10 to 15% annual energy savings. So we saw their study, and we set out to find out the same information, but for our coil restoration and tube restoration process. So we did this study in 2020, coincidentally also in New York State, on a 50,000 CFM air handling unit. The air handler was instrumented looking at 9 different parameters, including temperature, humidity, airflow, chilled water, delta P, and so on. You can see some of the equipment used to collect the data. We performed the coil and tube restoration on this unit as well. And these measurements were taken pre and post to accurately show improvements and compare to a baseline. So here is what we found. The first thing we found in airflow was the same 14% increase as the ASHRAE study. And as I mentioned before, this is a pretty significant increase in airflow. The average increase we typically see is more in the range of an 8 to 12%. And secondly, we measured an increase in the cooling capacity of 37%. And this is significantly more than the 16% achieved by the ASHRAE study. And this we would expect due to the higher performance process we're using for cleaning, also because we added the interior tube restoration as well. We also measured ATP, which they did not measure on the ASHRAE study. As you may recall, this is the test we use to measure the biofilms on the coil. We measured a 5700 pre-test and a 0 post-test. And for a frame of reference, 5700 would be considered significantly contaminated with biofilms. So based on this information, we can estimate a savings well above the 10 to 15% range that we found or that ASHRAE found in their study. So we took this a step further and we measured the actual dollar savings that could be found here from this particular air handler. So first, we found an annual energy savings from the blowers, 36%, an annual energy savings from the pumps and chillers at 32%, combined for an average of 34% total savings, which at the utility rate for here, this particular area was 12 cents per kilowatt hour, which equates to 43,627 annual cost savings. And note too, that we did not include any savings from the cooling towers or condensate water pumps. So there is a potential here that these savings could actually be even higher. So to summarize, the coil and tube restoration, one, unlocks capacity by as much as 35%. And one thing I'll mention here is you could take advantage of the increased performance as a dollar savings by lowering your use, say if you have VFDs, or you can actually take advantage of the increased capacity by utilizing that extra cooling ability. Like say your set points aren't being met in a certain area, the energy savings won't change, but your ability to cool a greater space or reach certain or higher set points will be available to you. This can renew airflow by as much as 25%, improve IAQ by eliminating the biofilms, and ultimately extend the life of your cooling coils. Okay. So just a brief bit about Aquis. We're a product service company based out of Orlando, Florida. We service the entire country. We were founded in 2006 for our coating system and comprehensive refurbishment of air handlers. We began offering our coil restoration and optimization in 2015. And to date, we've done thousands of units across the country for healthcare, primarily our top vertical. And as you can see here, a couple of our customers: healthcare, higher education, federal government, and manufacturing. A lot of the manufacturing too is we're finding more pharma as well. And that's it. Any questions, comments, concerns? Back to my screen here.
Good morning, Mike. I have a few questions.
Okay.
In regards to tube restoration, where you are pushing the dense foam through the coils, you were mentioning that you were addressing mic as
Correct.
well as scale.
Correct.
Does the probiotic remove both or just the mic?
So the probiotic is going to affect the biofilm, and those biofilms are going to create, it's what creates that mic, right? And produces the corrosion. It's microbial induced, so we're eliminating those microbes. The scale, when you're talking about the actual mineral deposits, is that what you're talking about? Just making sure.
Yes.
So we're going to be able to remove any of the deposits that are in the tubes by using that dense foam, and it has like a hammering effect to it. And we're putting air in the system to agitate and lift. As far as if your water is, I say, we can't fix bad water, right? If you're using water that has a lot of lime scale and minerals in it, the formation it'll form more quickly. So we can't stop it because it's in the water, but we can remove whatever has been built up to improve that airflow or water flow. Sorry.
Okay. And my second question is, on your videos that you were showing, you showed some coils that were in fairly good condition. There are a lot of people that perform coil cleaning like yourself.
Mm.
How do you approach a coil that's like 20 years old, where the fins are literally like, as crispy as potato chips? How do you approach cleaning that coil?
Yeah, absolutely. So there are limitations to what we can do. And there's a couple things. When we look at a unit and we have to do an on-site assessment, right? To look at the coil. I always put my hand on it, and if I can wiggle it, or if I run my finger across that coil and it just crumbles like a leaf, that's going to be a unit that we just can't address. We've, throughout our years of doing this, we have run into one or two where we start and the fins basically start to blow off, and we just tell the customer we can't go any further. It's beyond repair at that point. And honestly, that's really a side effect of the years and years of using caustic and acidic chemicals, right? On those aluminum fins. They may look nice and shiny and clean, but every time you use that acid, you're taking off a layer of metal. And if you clean them over and over again like that, they're gonna turn into thin little wafers. So again, there are limitations. Same thing. So I'll mention that too. There are limitations too to how we can penetrate. There's some coils that we're showing 7 or 8 inches of static pressure. Those coils may be beyond repair at that point. So other coils we've seen may have had issues with the environmental changes in building construction next door, and maybe cement-like or concrete dust has gotten inside the center of that coil and solidified. At that point too, we'd say they're beyond repair. But really what we're trying to do is also address coils before they get to that stage, right? Making sure there's a program in place to, keep an eye on those and make sure they're being properly maintained before they get to the point where they're fouled beyond repair.
Any other questions for Michael? Well, Michael, thank you and Akias for sponsoring this event and providing the educational series for us.
Sure.
Much appreciated.
Absolutely. Yeah. If you have any questions, there's my info. Feel free to reach out to Lupe or myself.
Thank you.
Thanks.
All right. So Joint Commission updates for 2022. We last year we went over the updates for that took effect on January 1st of 2022. Now we're going to take a look at the new standards that go into effect in July. So next slide, thank you. So ECO 2033, hospital conducts fire drills. They're removing alternative methods to provide some clarity. Next slide. So overhead announcement of code red can be used now, or they're clarifying. If your system is capable of bypassing audible alarms, the system must be activated to ensure transmission to the signal to the central station or monitoring company. Next slide. So here again, we're talking about the alternative methods removed, same as EP1. And then they're given, next slide, we're given clarity on fire drills, but must vary at least an hour for each shift, quarter to quarter for 4 consecutive quarters. So this is a rolling 4 quarters that you'll be expected to be able to document the various times. This is a new EP. requiring annual drills in operating rooms. Next slide. And we have another new EP requiring the timed evacuation drills for hyperbaric areas. This has always been in NFPA 99, but now they're creating a specific EP for it. So these are two new ones. We'll see a little bit later that two have been removed. So it kind of balanced out. So EP02, 03, 05, next slide, I'm sorry. 02, 03, 05, maintaining fire safety equipment within the building. So it's been reworded. And so if we go to the next slide, reworded and added language for other supervisory initiating devices. Next slide. So these are the two that I was mentioning that were removed. So EP7 for the semi-annual water level alarms, EP8 for the cold weather temperature alarm. While they've been removed from the Joint Commission standard, they're still required per NFPA 25, 2011 edition. Next slide, please. So this is how the fire pump EP11 used to read. One more. And they've added testing of supervisory signals for pump running and pump power loss. Next slide, EP14 talks about carbon dioxide and other gaseous systems. Next. So what they did was they increased the frequency for halon testing from annual to semi-annual. Next slide. New EP again, requiring hospitals to report all incidents in which medical equipment is suspected of contributing to death, serious injury, or serious illness as required by the Safe Medical Device Act of 1990. Next slide. So they completely reworded this slide talking about smoke control systems. Move one more, thank you. So basically allows for existing smoke control systems that do not meet the requirements of NFPA 101/2012, 19771 to be allowed with the approval of local HJ. Next slide. That's it. Any questions? Well, great. If you have some, you can email them to me and we can try to address whatever questions you might have. Brian, do you want to go through the announcements?
Yes, good morning, everybody. And thanks everybody for plugging in today. We had made a really strong effort to meet this month in person, but as everybody knows, as the Omicron variant was gaining momentum and changing the narrative, we decided to go virtual. But with that being said, we are looking for facilities to be able to offer their premises for future meetings. So if you've got the room or if you've got a conference room that we can hold future meetings, please reach out to me direct. We'd love to talk to you. Today's presentation is being recorded and will be available at cc.org. And for all new members that have joined on today, you get the benefits of not only joining in live, but also reviewing past meetings from other chapters. Speaking to facilities directors, have you had a recent survey or a mock survey? Would you be willing to share lessons learned with the group in the coming months? You know, just some simple information that will help other directors that may be in line of having their survey done at their campus. Please reach out to me. We'd like to just maybe put something together briefly for upcoming meetings. And lastly, the dates for annual and Southern California, Northern California seminars. CSHI 49th Annual Institute, again, is in June 2022 at the resort at Squaw Creek. CSHI Southern California seminar will be held in September this year in Long Beach, and CSHI Northern California will be held in October of this year in Fairfield, California. And that's all I've got, Tom. I'll send it back to you.
Great, thank you. Just a couple announcements. Again, I want to, share my appreciation for everybody joining today. I know we're all busy with dealing with the effects of COVID right now and shortage of workers and everything. I want to give a shout out to Michael Murphy. He was a new member who signed up in December, so welcome, Michael. And I wanted to announce, so as I mentioned at the beginning of the program, that Brian Campaign with Forensic Analytical is donating a Starbucks card. Beth did the drawing, and Rich Hewitt from Huntington Hospital is the proud winner. So we'll reach out to you, Rich, to get your contact information so that they can get that card to you. I want to thank our gold and silver sponsors. Without your sponsorship, the organization would not exist. And if you have topics that you would like to have us discussed, please bring them forward. This program is for each of all of you, and we want to bring relevant topics that are meaningful to our team. Are there any comments before we close? All right, go ahead, Dean.
Morning.
All right, well, thank you all and have a great day, and we'll see you next month.